A very good morning, students. We are back with our structural geology video lecture series, and today's topic of discussion is the concept of detailed structural analysis. And in this video I will try to explain what is a geometric analysis, what is a kinematic analysis, and what is a dynamic analysis in terms of structural geology. So with this mind we'll get into the heading, and before entering into the heading we should know what are the tasks of a structural geologist, and we'll try to break those tasks under the three headings that we had explained before. Okay, so the very first thing what a structural geologist used to do is he used to collect the data from the field, just like a rock type, the structures, its orientation, all those things. What are the structural data as well as the lithology data that he found in the field used to be collected from the field. The second step is map preparation. That is, after getting those data from the field, the structural geologist has to prepare a detailed geological map with all those structure to be mentioned in this map. Okay, so the third thing is interpretation. Just in the field, when you are collecting the data, a structural geologist used to have a generalized idea about some sort of structure that is present in the region. But when you are preparing the map, and after seeing a bird's eye view of those region, you can get more detailed idea about those structures that is present in the region. Not only that, after interpreting, he can explain the forces that actually causes the formation of those structures in this region, and the tectonic stress or direction of tectonic force that actually acts in this region. So this is what in general a structural geologist used to do. That is, he ultimately attempt to place the formation of structures and system of structures in the context of overall geological history of those regions. So that is what in general a structural geologist is trying to explain. So to do this, he actually has to do three fundamental analysis or three fundamental stages of analysis. The first one is the geometric analysis, which mainly deal with the mapping, measuring, and explaining the geometric analysis that is required to establish the deformation as descriptive analysis. Like, he have to explain or he have to describe the way in which the rock has been deformed. So that comes under descriptive analysis. The second phase is the kinematic analysis, which is the displacement as well as the strain. That is, the describing the deformation history, especially the strain, the displacement, the rotation and deformation path as kinematic analysis. So that is what he is trying to explain in this phase of analysis. The third one is the dynamic analysis, which mainly deals with the forces, stresses and the strength of the rock body that is present in this region. So here he used to think of interpretation, that is the origin of the structure in terms of force, stress and material behavior, as dynamic analysis. So these are the three main phases of detailed structural analysis here. Each phase has its own point of view. That is, all those phases we will try to explain different thing, and at last we have to combine all those things under the heading called detailed structural analysis. Okay, so for an analogy we will try to explain these three phases as three things that we know in our day-to-day life. That is, the descriptive analysis as an external appearance of a car, the kinematic analysis which is just like the engine that actually runs the car, and dynamic analysis which is the fuel that actually runs the engine. Okay, so just for a comparison, I'm just comparing these three phases as the three known thing from the real life example. Okay, we'll try to explain this. The first one is the descriptive analysis. Here the main concern is with the location, the geometry as well as the orientation. So these are the three things that we have to explain during the descriptive or geometric analysis. Here you can expect the transformation types, that is just like a gear in the car. You can expect four sort of transformation during the deformation. The first one is the translational movement, which is the change in the position of the rocks. The second one is the rotational movement, where there is a change in the orientation of the rock. And third one is the distortion movement, where there is a change in the shape of the rock. And the fourth one is the dilation, which is there is a change in the size of the rock. So these are the four possible transformation that actually happens in a rock during its deformation, which we are trying to describe. So what are the things that actually controls the way in which the rock deform comes under two main heading. One is the rigid body deformation, other is the non-rigid body deformation. So when you are studying about the origin of fall during our previous lecture videos, you can cross check that. There we had discussed classification of rock according to the strength into two broad categories. One is the competent rock and other is the incompetent rock. The same thing is explained here with the rigid body and non-rigid body behavior of the rocks. This we will try to explain in the upcoming videos. For now, we will just skip this point and we will go for the next heading, that is the kinematic analysis. That is just like the engine that actually moves the car. So this is how the rock actually moved. That is the motion of an object leading to the deformed state without referring to the force that actually causes the motion. So this sort of analysis comes under the kinematic analysis, which is just like an engine of a car. So here we have two things to explain. One is the displacement vector, the other is the deformation path. So these are the two things which has to be explained in this kinematic analysis. So we'll see an example for that. So let this be the undeformed or the original object, and these are the four possible way a rock can deform, where the top two are rigid body deformation, where the bottom two are non-rigid body deformation. That is, in the top two you can see only there is no any change in the size of the squares, right? So there is no any change in the internal arrangement of the rock. That comes under rigid body transformation or rigid body deformation or whatever it is. And in this case, that is the bottom two, you can see there is a change in the shape, size, orientation of those internal structure. That is, there is a change in the internal structure. That comes under non-rigid body deformation. So we'll take this as an example where A point has been moved from here to here and B point from here to here, whereas C, D, E and F, all those 4 points have moved in different direction with a different intensity. So when you are dealing about this thing, that is the direction in which the rock moves, that comes under displacement vector, whereas deformation path explains from the initial stage to the final stage what are the different phases that the rock has undergone. So if you try to explain these things, that comes under deformation path. For example, if you are moving from, say, my hometown Karaikudi to Trichy, there are 3 to 4 paths to move. So whatever the path that we get, that comes under deformation path, and the initial and final stage, that is the from Karaikudi to Trichy, that direction indicates the displacement vector. Okay, so this is what in general the kinematic analysis will try to explain in the structural analysis. Okay, is that clear? Okay, so now we move to the last heading, that is third heading, that is the dynamic analysis. So here we interpret the deformation in terms of forces and stresses that is responsible for the formation of structure, as well as evaluating the strength of the material during deformation. So here we are trying to explain what are the forces or stresses that actually moves the rock. Not only that, how the rock has been behaving for those sort of deformation. So here this is mainly of interpretive path. From the data that we found in the geometric as well as kinematic analysis, we are trying to interpret the final thing, that is the dynamic analysis, and the main thing here is the rock mechanics and the tectonic force that actually moves the rock. So this is what a dynamic analysis is trying to explain. So what is a detailed structural analysis? If you ask, I will tell you in a short form. That is, if you are going to the field and recognizing the secondary structures and measure those structures, that comes under geometric analysis. And we are trying to explain or recognize those movements that occurs during the formation of those particular structure, that comes under kinematic analysis. And if you are trying to interpret the force, the stress and the mechanics that produce the structure, that comes under dynamic analysis. And all these analysis put together will form a detailed structural analysis. Is that clear? Okay, if you have a doubt, mention in the comment section. I will try to explain in the upcoming video. We'll try to see in detail what are the next level of structural studies in the upcoming video. Thanks for watching. Have a great day.